A 760 million active parameter model just matched Claude 4.5 Sonnet on competition math, and it did it on AMD chips, with a trick called Markovian RSA. Let that sit for a second. This is Zyhra 18 billion from Zyhra, dropped May 6, 2026. 8 billion total parameters, under 1 billion active. Apache 2.0 license, waits on Hugging Face, and a tech report that introduces a new test time compute method that is genuinely worth understanding. So what is it? Zyhra 18 billion is a mixture of experts' reasoning model. 760 million active params out of about 8.4 billion total. Trained from scratch on a custom AMD cluster, 1024 MI300X GPUs wired together with AMD Pensando networking. No NVIDIA, no CUDA, just AMD, end-to-end. That alone is a story. Since 2023, frontier training has effectively required NVIDIA. Zyhra 18 billion is the first major reasoning OE shipped with a full public tech report trained entirely on AMD, which means a second source actually exists now. But the real headline is not the chips. It is what Zyhra figured out about test time compute. Architecture time. Zyhra 18 billion is built on Zyhra's MOE++ stack. Standard sparse mixture of experts at the core, with two unusual choices baked in. First, reasoning data was included from pre-training onward, using something they call answer-preserving trimming. Most labs add reasoning during fine-tuning. Zyhra started it on day one. Second, they replaced standard attention with compressed convolutional attention, which shrinks the KV cache by roughly 8 times. That is the thing that lets an 8 billion-sized model run real workloads in 16 gigs of VRAM. So you have a small, dense, in-capability, sparse in-compute model, fine. But none of this is the trick. The trick is what they do at inference time. Okay, Markovian RSA. Pay attention here. Recursive self-aggregation, the RSA part, comes from a 2025 paper. The idea is simple. Instead of running one chain of thought and hoping it is right, you run a bunch in parallel. Then you take those reasoning traces and feed them back into the model as evidence and ask it to generate a new round of reasoning conditioned on the previous attempts. Repeat. Each round refines the pool. Each round gets smarter. Sounds great. There is one problem. The context window blows up. Round 1 is fine. Round 2 has to read round 1. Round 3 has to read rounds 1 and 2. By round 6, you are dragging a novel through every forward pass and your inference cost explodes quadratically. That is where the Markovian part comes in, borrowed from a paper called Markovian Thinker. The insight: reasoning does not need full history. A Markov chain only depends on the current state. So instead of forwarding the entire previous trace, you forward a fixed length tail. In Zyhra 18B's headline configuration, that tail is 4,000 tokens. So the actual pipeline looks like this. For each problem, generate n parallel traces. Let each one run up to a 40,000 token budget. Take the last 4,000 tokens of each trace. Use those tails as the evidence pool. Sample a few of them, build a new aggregation prompt, and start the next round. The context window stays bounded forever. The model can reason for, in principle, unbounded total compute. And because rounds are independent, you can run all n traces in parallel on a single batch. The GPU loves you. But here is the kicker, and this is the part the paper hammers. You cannot just bolt this method onto any model and expect it to work. Zyhra trained Zyhra 18 billion specifically to use Markovian RSA. During supervised fine-tuning, they constructed synthetic aggregation prompts and taught the model to read tails and produce a better answer. During reinforcement learning, a portion of prompts used the Markovian RSA workflow, so the policy got rewarded for being good at the aggregation step itself. When they tried the same inference scheme on a Quinn 4 billion model that was not trained for it, the uplift mostly vanished. The harness and the post-training have to be co-designed. That is the real research contribution, not the trick itself. There's also a 4-stage RL cascade behind this. Stage 1, reasoning warm-up on math and puzzles. Stage 2, a 400-task RLVE gym curriculum where puzzle difficulty adjusts dynamically. Stage 3, the heavy math and code RL with test time compute traces and synthetic code environments built from competitive programming. Stage 4, a lighter behavioral RL pass for chat, instruction following, writing style. And underneath all of this, a thing called router replay that forces the trainer to reuse the exact same expert routing decisions during gradient updates. Without it, MOE RL goes unstable fast. Now, the numbers. AIM-A 2025. Single rollout, no tricks. 89.1%. Turn on Markovian RSA with a 40K budget and a 4K tail. 91.9. HMMT 2025. 89.6%. That is above Claude 4.5 Sonnet at 88.3 and above GPT-5, high on the same benchmark. LiveCodeBench v6, 65.8. IMO Answer Bench, 59.3. GPQA Diamond, 71. All from a model with 760 million active parameters. For comparison, DeepSeek v3.2 has 37 billion active params. Zyhra AI 8 billion is roughly 48 times smaller in active footprint, and on the Apex shortlist math benchmark, with an extra high compute budget of 5.5 million tokens per problem, Zyhra AI 8 billion actually beats DeepSeek v3.2 and GPT OSS 120B High. That is the move. Spend more compute at inference. Approach frontier scale with a tiny model. The obligatory eyebrow raise. These are vendor-reported numbers. Zyhra picked the benchmarks. The headline 91.9 on AI Assistant 25 uses Markovian RSA, which costs a lot more inference compute than a single shot. The fair apples-to-apples number against a single-chain model is the 89.1. Still impressive, just not the same number. On broader knowledge, larger models still win. MMLU Pro and GPQA Diamond, the big proprietary models, hold the lead. An 8 billion parameter model cannot store the same amount of world knowledge as a 671 billion one. Zyhra 8 billion trades factual breadth for reasoning density. That is the trade. So what changes? For researchers, the real takeaway is the co-design point. Test time compute methods are not free upgrades you slap on at the end. The model needs to be trained to play along. That changes how you scope a reasoning project. Inference strategy is now a training decision. For developers, you can actually run this. 16 gigs of VRAM in BF16, 8 gigs with 4-bit quantization, that puts frontier adjacent math reasoning on a 4060 Ti. The Apache license means no friction. For AMD, this is the cleanest credibility win they have had in AI infrastructure. A real frontier reasoning model, fully trained on their stack, with a public tech report. Procurement teams that were locked into NVIDIA by default now have a working example to point at. For NVIDIA, nothing immediate, but this is the kind of result that makes a long-term moat look slightly less infinite. For the rest of the small model crowd, Markovian RSA is now the obvious next thing to integrate. Bounded context, parallel rollouts, recursive aggregation. The recipe is in the paper. The hard part is the training code design, which is exactly the part that takes a serious team to reproduce. Caveats: independent reproductions have not landed yet. The 5.5 million token compute budget on Apex is huge by any normal definition of inference cost. The model is small in active params, but it is still 8 billion total, so memory bandwidth still matters. And we have not seen long horizon agentic results, which is where reasoning models really get pressure tested. But the core idea is clean. Unbounded reasoning with bounded context. Trained into the model, not bolted on. From a lab that fits on a small page. On hardware nobody expected. Here's the part that should keep frontier labs up at night. Capability density, the amount of intelligence you can pack per parameter, has been roughly doubling every 3.5 months. Zyhra 8 billion is what that exponential looks like in practice. A model 30 to 50 times smaller than the leaders on the same problems, trailing by single digits. If that trend holds for another year, the gap between a tiny lab and a giant one stops being a wall and starts being a tax. Markovian RSA is just one ramp on that curve, and it shipped from a team most of the AI world had barely heard of. If you would like to hear and see the latest news about LLMs, then like and subscribe.